Hi, Dynami Battery Corp is enabling the next generation of batteries by electrode microstructuring because new chemistry is not enough, and battery cells uh, need engineering to fulfill the promise of a decarbonized world. Next, please. I can speak of the opportunity as $1 trillion market, or I can tell you that the European Commission banned internal combustion engines from 2035 in the next but there's something that is much bigger than that. There's only once in a lifetime that internal combustion engine cars will turn into battery powered electric cars, and that time is now. So all the rest of the arguments are very small compared to the market opportunity we have today. Next, please. What is the problem? The problem is that, no, previous one. The problem is that the batteries are made using obsolete equipment, and there's lack of further engineering, and the equipment used to use these batteries, especially the electrodes, it's almost 100 years old. So it's not well suited for engineer electrodes that have microstructures. Next, please. And that leads into the problem that batteries with no sophisticated engineering lack fast charging. And fast charging is very important for electric vehicle adoption because it mitigates charger congestion, and most importantly, range anxiety, which is one of the big showstoppers in the EV industry. Next, please. Our solution is that we have developed a manufacturing technology, an additive manufacturing technology that creates microstructure battery electrodes, and we have patented that. Next, please. Our technology leverages self-assembly and self-segregation at the microscale to form honeycomb-shaped electrodes that introduce something that is well known for the battery science community, which is secondary pore networks. We have filed patents for this technology in February this year. Next, please. Here you see a scanning electron microscopy image of our electrode. As you see, these are about 70 microns in diameter. That's about half the size of a human hair. And on the right, you see how the honeycombs implement secondary pore networks, which are similar to lithium ion highways. That is, the lithium ions can go faster through these less dense areas, making batteries that charge faster and also have higher power. That is without changing anything related to the chemistry nor the architecture of the battery. Next, please. We are in the process of integrating these electrodes both in our laboratory and using third-party laboratories like Spectra Power. Next, please. The important thing about our technology, our fabrication technology, is that it's a drop-in solution into current production lines. The only thing that has to be changed for any battery cell manufacturer or car manufacturer to introduce to produce a battery that has faster charging using Dynami technology, they have to change the coating of the electrode. And a side effect of this is reducing the electrode manufacturing technology, the electrode manufacturing cost by 80%, because we use infrared drying, which is what is the single most energy consuming part of the electrode manufacturing. Next, please. We have a competition. but we feel that our technology, and we have studied that our technology has some attributes that our competitors don't. Most importantly is that we are chemistry agnostic. That is, our technology works with today's lithium-ion battery cells, like the ones with liquid electrolyte, but it also works with solid states. It also works with metallic lithium anodes and many others. And that's an important advantage. Next, please. Our market, our go-to-market strategy is providing electrodes to battery or EV manufacturers. We can both cater current generation manufacturers, like the ones on the left, but also next generation manufacturers, like the one on the right. That is because our additive manufacturing technology is compatible with most substrates, that is current collectors, the thing where the electrode is coated, and hence being able to adapt to all these technologies. Next, please. This is the type of profit we expect out of the commercialization of our technology. And the important part here is that since we make cathodes and anodes, but most importantly cathodes contain about 50% of the total material cost of the battery, which is the total cost of the battery, that is in raw materials. That gives us a big opportunity to add value to those raw materials and hence have a high profit. Next, please. This is our growth plan. We are in an integration plan. In an integration step, we are 70% there, and for that we opened a 1 million round, which is 62% raised. And the activities of the use of this fund is for third-party integration that we are doing at Spectra Power in California, IP protection. We filed patents in the US and most of the world, and establishing a Maryland laboratory. Today, Dynami Battery Corp has a laboratory in Buenos Aires, Argentina. Dynami is a Delaware corporation, but we are working on opening our laboratory in Maryland. And also about this, we are also applying to. We have teamed up with Outreach National Labs to apply to an ARPA-e opportunity, fund opportunity. So we feel like this is a way to leverage the resources we have today. Next, please. This is our team. It's composed mainly of engineers and Professor Brent Goldfeld from University of Maryland, and most importantly, John Lau, that is it's an MEIA executive in residence that now is part of Dynami's team, and he's working hand to hand with us. So thank you for your attention, and any questions you have, we are open for it.